In my previous video, which I have just released, I showed you my new radiant half-bridge circuit and I did some tests with it. Right now I will show you another experiment which shows a triangle wave and a strange phase shift. This is the half-bridge radiant circuit. I've got a larger L1 coil on the bottom. As you can see, the L2 coil is now in my hand and the L3 coil is on the top of the L1. The L1 is larger and this has a reason. I've made L1 bigger, so L2 will have a relatively smaller inductance than L1. This makes it possible for the impulse of L1 to make a bigger current amplification in L2. This is called parametric resonance. This means part of the resonance is taking place with a different value of capacitance or inductance, which creates amplification. L3 is the output coil to the lamp and is parallel tuned by 61 nanofarads. I have a 2.5 millimeters distance holder, which isn't perfect because the cables are on the wrong side. Then L2 comes on top, series resonant, and it is flipped over. So it's not like this, the red color on top, it is flipped over. So that makes it phase reversed in relationship to the other coils. Series capacitance now is a little bit smaller than the L3. The L2 series capacitance is 51 nanofarads. I got the current probe and the high voltage probe in yellow, and the high voltage probe in orange is on L3. I'm going to show you the waveforms. Right now I'm at 49.3 kilohertz. I'll switch over to the scope and show you the strange waveforms of L3 while tuning up. Here is the scope shot. In purple again you see the half-bridge voltage that is supplied to the coils, high and low. We'll now dial in some power so we get a signal. There it is. I've got 2 times 4 volts DC at 1.5 amps DC on the input power supply. I switched off the lamp, so it's only the parallel resonant L2. I'll make the sine wave of L2 a little bit bigger. As you can see now, L3, which is in orange, is out of phase with L2. And this is because I flipped over the L2 coil. This means this is the transverse resonant mode, whereby voltage and current normally are in phase, but because I flipped over L2 it is out of phase. I will now turn on the current again, which is green. This is the current of L2 series resonant, and I will start going up in frequency, tune it higher. So I'm starting at 49.3 kilocycles per second and I'm going up. Nothing special here. As you can see, the current is decreasing now. It is not amplified by the impulse, which I showed in my previous video. But look at that waveform of L3. It's becoming very strange. Now I'm tuning even higher and now the current is being amplified while L3 is a triangle wave. Let me make L3 a little bit bigger. Look at that, it's a triangle wave. I don't fully understand that. Triangle waves are normally differently produced, so I need to analyze what is going on here. So 56.4 kilocycles per second. My power rating is 1.28 amps at 4.1 volts DC. And I'm going up in frequency. Now you see the current rising again. The green sine wave is getting bigger again. Very odd, very strange. Now L3 begins to distort. It is heavily oscillating in high frequency, and I'm going further, it is still all amplified. And now L3 starts to become 0. And it is flipping over. And that is what I wanted to see, because they had to become in phase, which is the longitudinal resonant mode. So I'll tune higher and higher, and yes, there is the L3 longitudinal resonant mode with L2, and you can see it is amplified again. It is much bigger than before. I go higher and higher and higher and higher. Very large amplitude. I'll change the scale so we can see the waveform. And well, that is about the maximum, so around here. This is 67.23 cycles per second, and I've got an input power now of 0.7 amps at 4.1 volts per channel. So I have less power on the input, but I have more power on L3. L3 now is 192 kilovolts. I could dial up everything a little bit higher, but this sequence is so very interesting to me. That triangle wave, and then L3 becoming in phase with L2, and it makes sense that L2 and L3, which now are in longitudinal resonance mode, because they are in phase, because I flipped over the L2 coil. In reality, they would be, or reality, when L2 wouldn't have been flipped over, it would have been out of phase, as I showed you in my previous video. So the L2 fields are assisting L3, and L1 is assisting L3. So L1 is magnetically inducing resonance in L3, and at the same time L2 is dielectrically inducing resonance in L3. I haven't got power right now because I could try. Let me dial down the power a little bit and turn on the lamp. Now I'll turn up the power again. So now I've got the lamp burning now. Let me show you that for a small moment. So you can see the lamp is now burning. It's connected to the circuit. But if you look at the scope shot again, you can see L2 and L3 now are 90 degrees phase shifted. So it isn't ideal anymore. They should be in phase. And when that has happened, depending on tuning, power should be generated from L1 and L2. The input power rating is 1.26 amps and 2 times 8.1 volts DC on the input power. Now I have tuned to the very unique situation whereby the impulse is tuned to the voltage minimum and the current maximum. Again, orange is the L3 voltage. Yellow is the L2 coil voltage. Green is the L2 current. My power input now is 0.38 amps at 2 times 30 volts DC. I pushed up the voltage because the amperage was very low and the impulses were rather small in this configuration. My frequency is 69.67 kilocycles per second, and as you can see, the impulse now is at the current maximum, and this makes it able to get very low input amperage. So I can push up the voltages really high. L3 now is 713 volts peak to peak, and I have 9.3 amps peak to peak in L2. This is very unique, as we now have 300 volts impulse that is in phase with more than 4.5 amps. So that is a lot of power. But it is only during the duration of the impulse. It is not constantly there. I'll zoom into the impulse so we can see how long that impulse is there. I'll put the cursor on it. That is 722 nanoseconds. So during that period, the voltage isn't zero in the series resonant coil, but the voltage is going up and down to 300 volts, while the current is maximum at its peak. So we've got now an impulse that should have real power. It's a very unique situation, this. The ability to tune the impulse to the current maximum. That concludes this test, which I really wanted to show you because it's so very interesting what is happening. The circuit is still not fully tuned yet. That's also why I didn't calculate the lamp output power, because it was obviously less power than I put into the circuit. This work is all open source, meaning that I will share all the information that I gain with the community that is interested. You can fund this open source research by giving a donation on my PayPal account that is listed below in the description of the video. If you have questions, you can do so in the comment section below. Please subscribe, like and share this video and turn on notifications if you want to get a personal call when my next video is out. Thank you for watching. See you next time.